enough for a basic search engine. But enough means shit if you're trying to get a job, so there are a few things that we need to change. The next few sections will talk about things that I think are very interesting, but I wasn't sure if the general YouTube audience would find interesting. So I deliberately chose them to put them at this point because hopefully I already have your attention by now. I spent a bunch of time working on this video, from the project itself to the script to the editing, and this is actually the fifth version of the script. There are a lot of things that I got rid of for the final version because they were not very interesting or they were just difficult to showcase in a fun way. So if you'd like to see the previous versions of the scripts with all the unedited things and also some extra content, you can become a channel member. Anyway, the next things I want to talk about are scaling up services, optimizing the spider, optimizing the indexer, creating a scaling service, implementing spell checking and a reverse proxy for the query engine, and finally, implementing the famous PageRank algorithm that Google uses. So let's just get into it, this shouldn't take that long. As you may have thought, or not, I don't know what's going on in your brain, having just one spider and one indexer is probably not enough to crawl this whole mess that we call the internet. Luckily for us, a very useful thing about distributed systems is that we can run multiple instances of the same service at the same time. So instead of having just one spider crawling the web, we can have a shit ton of them doing it at the same time. And the same goes for other services. Which is perfect because this means that if your computer is not powerful enough, you can just run a bunch of spiders in other computers. This is called horizontal scaling, and companies usually do this with clusters of servers in the cloud. But this brings up another issue. If the services are all running on different machines, how do they talk to each other and synchronize? We don't want the spiders to crawl the same pages multiple times. To fix this, I'm using Redis. In simple terms, Redis is a database that works in RAM instead of disk storage. The reason I'm using Redis is because it allows me to have different message queues that the services can access to synchronize with each other. So remember the queue I mentioned for the spider? Well, now each spider accesses a remote message queue in Redis. This helps reduce the possibility of crawling the same links multiple times. There are other message queues for other services, but it is not necessary to explain them for this video. The other thing I need to mention is that to actually store data that will be accessed later, I'm using MongoDB, a NoSQL database. So in this system, Redis is used for communication between the spiders and the indexers, and also to store some temporary data, but then all the important data is stored in MongoDB, which is what the query engine will access. With that being said, I decided to deploy my spiders in the cloud. And by cloud I mean this computer that I stole from the trash that I'm using as a server. See, all the previous points about horizontal scaling and distributed systems were pretty much useless since I don't want to pay for cloud. However, I did design the system with that in mind, so I should perfectly be able to run all these components in a distributed way once I have the resources. There is one small trick that I used to improve the spider. I changed the spider queue to a priority queue. Why? Because it made sense to me. Here, if a link is being referenced by a ton of pages, it must be important. And if it's important, I want to process it earlier. So if a link is added to the queue more than once, its priority will